Hi, I'm going to get started. I'm the professor, Ben Holverda, and I'll be your lecturer for the semester on astronomy. Hey, we're in the most astronomically themed room in the whole of campus. Welcome to the planetarium. We'll use the planetarium on occasion to get a concept across, like today, hopefully about the scales of the universe. Today is about the class policies and like how you get, how the grade is calculated, what I'm expecting from you. I know it's all in the syllabus. I've also been a professor long enough to know how many people read the syllabus. So here's sort of the verbal version of it. There's also recordings of these classes. Again, if we do the planetarium stuff, it does not get captured by my iPad, too bad. But you can miss a class and sort of catch up with what happened. So I try to have a slide like this at the beginning and the end of every class. So what we're going to talk about today, what's happening next class. Next classes, next week, I will not be here because I am taking a whole gaggle of students to the American Astronomical Society meeting in Washington, D.C., provided the airfield is open. And so I can't be in two places at the same time. So here's sort of the basics. Typically I'm in Natural Science 133, but I'm currently homeless, so I'm finding a spot for drop-in hours. So as soon as I have a location for that, there will be a place on Friday afternoons for you to drop in if you have questions. Other than that, I've noticed that most people just go like, well, I know where you are right after class, so they just grab me after that. That's perfectly fine too. There's one required text from OpenStack, so you'll hear about that in a little bit. And so that's sort of the basics of the class logistics. We're here in the planetarium. Drew is not here at the moment, but please take care of the place. It's just me and him taking care of this area, so nothing worse than having a sticky floor because somebody drops some Coca-Cola on it. I will also say that these chairs are quite hungry for your wallet. They're nice and comfortable, and if you fall asleep, that's on you. I will not wake you up, but I will also not ding you for it. I know how nice and comfortable they are, but it's very easy for your wallet or something to slide between. The number of times that I've had to sort of rush back and give somebody their wallet back so they can get into their dorms, or give them their guitar back. That was a new one. But anyway, so it's easy to drop something here between the seats, so check your seats when you leave. I just got my planetarium driver's license, so if I occasionally break the universe, I will have to go to Peru, please help me. So try to be patient. So we're here, and obviously because you found the place, I'm including the slides for everybody who's reading this later and going, oh, that's where we're supposed to be. So this week we'll talk about course policies, science vocabulary a little bit, units, which is important, and I've noticed that last semester, one of the feedbacks that I got was like, hey, can you emphasize the units a little better? We'll take the astronomy survey, so I have a pre-class test. You go like a test already? Yes. This is the test that I'm giving to you all so that I know how I'm doing. I'm giving it beforehand and afterwards so I can improve my teaching. And then we'll talk about who is a scientist and what is astronomy exactly. So this is where the crash course YouTube video came in. If you want to wear a mask, feel free. It's no longer mandatory, but if you feel sniffles, if you kind of go like, I tested positive for COVID, feel free to stay home. That's cool. There's no mandatory participation in this class, and if you want to wear a mask, that's cool too. If you want to point something out that I'm doing that I shouldn't be doing COVID-wise, you should totally use the magical phrase, you can't be doing that. I have really only one rule for the classroom, which is you shall not interfere with the learning of others. And that covers a remarkable number of things, but it really comes down to if you're doing something in class that bothers other people, I will either ask you to stop doing it, and otherwise ask you to leave. That includes to watching cat videos or something loud on your phone. It covers a whole bunch of things. Basically, rule 1 covers most things that I need to cover. You do not hinder the learning of others. So there's a bunch of online stuff. I've put everything in Blackboard already. If you check the Blackboard of this class, everybody's getting used to. I'm still getting used to Blackboard Ultra, but I will have every online component, so basically everything you need to do there, the pre-class assignments, the homeworks, everything is there, and that's also where you upload it, and the pre-class videos are accessible there. The class recordings will be there as soon as I've got it off my iPad and put it on Blackboard. The slides will be there. I try to have them online as a PDF before the start of class in case you want to take notes on them, for example. Lots of people have iPads that they might like to write on. You can load the PDF. You can do it communally. Bring your devices. So it's perfectly fine in this class at least. So again, it might differ from class to class, but here if you want to use your whatever device to take notes on, I get it, but in a way that doesn't violate Rule 1. Again, loud music from your laptop will not be appreciated by the rest of us. And so, for example, you can take notes collectively. I noticed this in the first class of the pandemic. I just casually mentioned, hey, you could take notes as a class, like stick it in a Google document or stick it somewhere and like everybody sort of comment on it. That worked phenomenally well. It was a smaller class, but they couldn't talk to each other, so that worked really well. The goals are to understand astronomical knowledge, like to understand the universe a little bit, the scales of it, how we got to understand the scales of the universe. So really appreciate why we did that and how we did that. And calculate a little bit, right? This is a science class, so we are going to use a little bit of math to get the concept that we're talking about and turn it into some numbers, to actually appreciate sizes of things, the scale of the various numbers. That doesn't mean it's a math-heavy class. There's just some math involved. And I always see some people sort of tense up when I even say the word math. This is the class for you. This is the science class for you. I'm happy to help. Not everything is something that you have to calculate. A lot of the questions will be concept-oriented, but there are some concepts that we then turn into calculations. Just appreciate how that gets done. So the setup is we have a pre-class assignment. So lots of you already did them. If you want to still go in and do it, we had one for today, which asked about how, who is an astronomer? And so these are questions about the YouTube video. We will go over a topic in 20 to 30 minutes, and then we do an in-class assignments. Why the 20 to 30 minutes? Well, I have a colleague, a good friend of mine, who studies how people pay attention in classes like this. After 20 minutes, you lost everyone. Nobody's remembering anything that you say after 20 minutes. So I was like, well, I can stop talking then, and we just do something, right? So break up the class a bit. There's a homework assignment. So you'll notice that there's 3 kinds of assignments already. And so all the slides, homework, pre-class assignments, everything is in Blackboard. Everything for the entire class for this semester is already in Blackboard. You can see what's there. You can see how far along we are, right? This is all visible to you on Blackboard already. Part of that is because I want to maximize flexibility for you all. Life happens, so if you want to go like, oh, I know I'm not going to be able to go there on Thursday, I'll do the pre-class assignment early. Or I need to do the homework because the team's being sent out, like I can do the next week's assignments already. It's all in there. So part of that is so that you can work ahead, or at least look ahead what's coming. So yeah, that's all in Blackboard Ultra. It's still a little new to me, so it's all been reorganized. So any issue that we're still having, point it out. Last semester, I tried to have an automatic calculation of how many points everybody had. It did not work. So again, I'll drop that one. I'll see if I can keep you up to date. So typical week on Blackboard, I can give you the list, but I'm also just going to show you on Blackboard. I do put the learning goals at the beginning of the week. There's an OpenStack, there's links to the OpenStax textbook. So I use the textbooks in the YouTube video sort of interchangeably. You can either watch the YouTube video or go into the OpenStax textbook. Some people like videos, some people like textbooks. Some of us with gray hair like textbooks that are made out of dead wood. It depends a little bit. The OpenStax textbook is completely online, so easy to read. But you can get it as a textbook. And so pre-class assignments before, okay, I thought I caught all the Mondays and Wednesdays in the slides. Those should be Tuesdays and Thursdays, yes? Okay, fantastic. So before class, you do the pre-class assignment. It closes on when the class starts. And then this week's slides and recordings for each class comes right after when I have like a Tuesday, Thursday in there. And then we have in-class assignments Tuesdays and Thursdays. That's the only thing that we do on paper. And so I have one for today, so you can just try it out. And the homework assignments, they're due on Friday, so they can be uploaded on Blackboard. Everybody's a lot more comfortable with that since you're all COVID kids. You've all had done some part of your education online, so much more has been moved online here. So if I say something like this, it just means that I make sure that I show you this. So here's the, how you get started. I think the syllabus is under here as well. So if you kind of go is there a policy around that? You can always go to the syllabus. Here's week 1. That totally has, some of the resources and our voting cards. Sometimes it's just a little thing like, oh, there's no class on Tuesday, for example. So it sort of goes through the whole week. So just to give an example, nothing next week. And then week 3, it has, what do we need to do? OpenStax chapter 5, so there's even a link to go to chapter 5 with everything that you want to read up on, if you want to read up on it. But the two pre-class videos that are needed. I have module objectives, so these are the sort of terms that I want you to take up on that week. And then here's the pre-class assignment, and here is the, where's the video? There's videos, and this is my time. It's I'll make this available as soon as the recording and slides are available. So you have here's the crash course video of that, and before it starts playing the inevitable commercial pre-class assignments and Thursday class. So everything is in there, and then homework at the end. There is a slide, or often a thing called extra material. That's where I host some extra videos if you're interested. Again, you don't have to watch those, but those are for fun. Okay. Excuse me. So that's how it's organized in Blackboard. Is that clear to everybody? Okay. You'll notice that at the moment you're nodding and everything, but I have an actual trick to get feedback from you all directly. Crash Course is my main sort of textbook. I really like these videos. They're now a little older, but they actually introduce the topic fantastically. So unless you don't like older references to the MSU, the Marvel universe, then other than that, it's actually quite up to date. It's all free. So another thing that I'm trying to do is make sure that the textbook and whatever else I'm using is all free for all to use. So there's no extra pay for homework, a homework system or what have you. Yeah, the orange, so I've moved that to a separate folder because I can't make links orange anymore. But that's, in case you go oh, this is a fun topic. Do you have some more videos? Yes, I do. So that's where I put in, for example, explainer links by my colleagues and friends who have worked on this. The book is completely free online, but you can get a hard copy. And I always have to have 1 or 2 students who go I don't know, for me it's a tactile thing. I would like a hard copy. That unfortunately costs money because it has to be printed, but everything else is already available, and I put the links in that first thing in Blackboard. So you can just go straight to the textbook if you want to read up on it. So then we do a pre-class assignment. It's in Blackboard, linked to the video questions. It's pass-fail, literally completed before class. That's it. That way I know that you've at least seen the concept once before while we get started on that in class. Really complete or not complete is what it should say instead of pass-fail. Just do them. If you do 70% of them, you get full credit. So you get credit for pre-class assignments, in-class assignments, and homeworks, and if you complete 70% of each kind, you get 30 points, which is total a third of the class. So a third of the class is stuff that you do in class. Then you have a midterm and a final. So each of these are equal amounts of points, 300 points total. I'll keep going over this. But the way that I've set this class up is that not everything is completely hinging on that one exam in the middle and then one exam in the final. Not everybody does well with, high stakes testing, and honestly, physics isn't high stakes testing. A pilot exam or a surgical exam is high stakes testing. This astronomy is not. You can go over to the library and grab a book. You can go look up what the answer was, right? This is not a high stakes thing. So we do constant effort over time. Really how science works as well. So do these exercises regularly, you get prepared for the midterm and the final, and that's why I do 70%. Why not 100%? Well, I also know that cars fail, the road is slick, you might not get it, or coach said that you're playing Alabama on Friday, so guess what? You're not going to be here that week. So that 30% is sort of when life happens. I will have some links to simulations, so these are fun little things that you can sort of play with. I haven't done assignments with them, but I find them sometimes useful because it's sort of in between a video and a in-class activity, so they no longer the case. That was COVID, sorry. In-class assignments are a group activity, so I don't want to see one name at the top of these little pieces of paper. It is where you get to meet your neighbors. So the 2 of you, or 3 of you, or 4 of you work out a problem. And so as long as you put your names at the top, this counts. It's 10 minutes or less, typically 6 or 8 minutes, I time it. Make sure that name and student number are on there, and then complete 70% of them for full credit, otherwise a fraction of completed. So for in-class voting and discussion, we use these voting cards. Who here has actually worked with clickers before? Do you like working with clickers? I certainly didn't, because somebody clicked on a button. I can't see. So I use voting cards, which is a little lower tech, but you can, you know what? I'll just start handing them out. Hang on to these. You'll have to break this out pretty much every class, because we sort of do multiple choice voting this way. Sorry, a couple over here. And we pass them on. I hand out lots of stuff during classes, but this is the one that I want you to keep track of. This is how you vote in class. This is how you give answers in class. So instead of saying like, oh yes, the answer was A or B or something like that, we'll have a little discussion. And the 2 of you have to, even if you agree, explain to your neighbor why you think that's the answer. And so this is a big part of the class and helpful for me, and you're gonna go like, well, why do you give us full color pieces of paper? Because I can immediately then see if one chunk of the class didn't get it. Right, so if I suddenly see like correct answer, wrong answer, I'm like, was I not talking to this part of the class? Maybe I should go stand here and do it again. Or if I go like, yeah, I see a mix, okay, I can move on, right? I immediately get feedback on how well we're doing with the topic. And I will say from experience that a topic that worked perfectly well last semester, I might completely flub this time. So I like, oh, okay, redo. Make sure that I explain it right. So this is how I get feedback literally directly from you. So for example, the shape of the Earth is flat, round like a pancake, a sphere, or a football. Now you can fold the right answer and hold it up accordingly. So I'll just stand here. You need one. Yep, this is the downside of the planetarium. If you're sitting in the middle, there's no way for me to get to you. Short of some acrobatics, so that's not happening. All right, voting in 1, 2, 3, hold them up. All right, sea of green, I think everybody got it, and we'll move on. The sun is one of a kind, a star, a planet, a football. Voting in 1, 2, and 3. Great, that's the mechanics of voting on this. And so Typically, within the first 5 minutes of a class, I'll ask a question, it'll be multiple choice, and you go, okay, we'll answer these. But also, these kind of, I'm not that original, these kind of questions are also on the midterm and the final. The midterm and final are part multiple choice and part a little more elaborated, where you actually have to explain your answer. So either explain your logic or do a calculated out. The homework are two kinds of problems. So they're typically reasoning problems. Everything's already available on Blackboard. They're due on Fridays. So pass 70% of them. There's only 12 of them, so pass about 8 of them, and then get full 30 points. I'm trying something new this year. So last semester and this semester, and these are homeworks by the Rubin Observatory. And so these are being made all over. And so you start with something like this. Start coloring the universe investigation. That's the next one. And so you answer questions. And then you move on to the next types of light, the electromagnetic spectrum. This is the one that we're doing in week 3. And you have to answer before you get to the next one. Like, it doesn't allow you to move, so you do have to answer. And all the way at the end, so you can see how far you get. If I haven't tried this, because my Spanish is non-existent, but you are perfectly welcome to do this in Spanish. And I would be keen to hear how good the Spanish is, and so are the people who are building this. They are building this for every aspect of astronomy. This is part of the Rubin Observatory, which is a new observatory which will have first light, so we will start observing this year. We've been working at this for the last decade plus to make this happen, so it's an exciting year that this is going to get started. And one of the things they wanted to do is explain it to everybody, so this is part of their strategy to sort of to do that. So there's a link here in the bottom of the homework, and it's like you click on it and you go to this page. Really important when you do that. So I'm just like showing you, there's a couple. Coloring the universe is the first one that we're going to do. You go over these questions. There's some real data that you can then work on and see what they're trying to do. And then at the end, where they're going like references, acknowledgement, funding support, thanks to Ant, so-and-so, right? They put everything at the end. There's a button called Review Your Answers. Please click that button, and then put your name and student ID at the top, and then you can scroll the way down, print your answers to a PDF. Please do the latter, not download your answers, because that's an Excel sheet, and while that's nice, it's really hard for me to read. The PDF is the easiest to check. So send me in a PDF, okay? Because then you download, like you print it to a PDF. Everybody knows how to print to a PDF. Question, yes?
So is the homework, does it like have a text to it, or is there some knowledge?
So it has text in it, and then you reason and answer a question. There's a thing like, well, which one do you think is brighter? Which one do you think is redder? That kind of thing. Here's a plot. Where does your point lie now? So sometimes you get an individual point assigned, and so you follow a supernova, for example. They're pretty straightforward, but again, if you have a like, oh my God, this completely stumped me, you should tell me, because again, we're developing these things. This is being developed by educators and the like. We have like giant telecoms about it to make sure that we got the wording right and that we're not obfuscating anything. Yes?
Does the platform tell you if answers are wrong?
Ha, no. So that would be nice, right? But I grade this, but mostly in a like, did you try to answer this, right? Are your answers consistent? My grader sort of grades these. Typically, complete the assignment and you get full marks. You get a passing mark anyway. But the important part is like make sure that you send it in PDF, because that's easier for me for all the stuff to ready. Okay. Any other questions? So this is not all of them. Yes.
So when you complete that page, it doesn't show us if we got it right or not. But
Yeah.
at the end, when we click does it show our answers?
Yes. So best part is like review your answers. They all show up, and then even then you can go through and go like, I'm not. You can actually go back and fix it.
Okay.
Yeah. Feel free to do this as a group, by the way, but I do grade you on individual. This is the only assignment that is individually graded. Okay, 3 class assignments technically as well, but that's pass-fail, complete, not complete. But make sure that you print your answers. Okay, so just did that. So you go to the Rubin link, fill out the questions, and print this PDF. Honestly, this is the important one. I keep telling them that they should just have a button that says turn into PDF. That was my first feedback, so we'll see if that arrives sometimes this semester. The homework is sometimes, like I only have 6 of those Rubin ones. They're also assignments that I made, and that's simply a PDF that's available on Blackboard. So you can fill, like, that's where you calculate something, that's where we work through a distance measurement, or where we work through something that actually requires a bit of math. Work out your answer on paper, but please put it then on a PDF or a photo and upload it on Blackboard. Yeah? Okay. Okay, so collaboration. Yes, because science is a collaborative effort. So please form study groups. Don't bang your own head alone in the library against the topic if you don't understand it. But please make sure that this is in your own words. When you understand it, that you then submit the assignment. Okay, so final grades. We have 2 exams, each for 100 points, and then 70% of the pre-class assignments, 30 points, 70 or more for the group assignments, 30 points, 70 or more for the homeworks, 30 points, 10 points of civics. Basically, if you're a good citizen, and honestly, the vast majority of U of L students are absolutely wonderful people. I just stuck that in for that, I don't know, 0.1% that tends not to be. So, if you do everything and basically don't violate Rule 1, you get 300 points total, plus there are extra credit opportunities. So, I have had people with, 320 points. That's fine, but, it doesn't get more A+y than that. So, there are different ways to get to your final grade. It also tells you that if there's extra credit, you can sort of boost, and you're kind of like, I'm not so happy with my midterm, you can boost it up, right? There's ways to boost your total. I'll try to have that calculate the fraction that you did so that you know how far in the 300 points you are at, right? So I tried to make that happen last time, all the time that didn't work. The bad citizens point, or the citizenship points, everybody starts with the 10 points, really you can only lose them. This is from a colleague. Honestly, I tried to answer bad emails, but you're making it harder for me if I have to track down what your student number is, or if you're in my 107 class. I've gotten ones from other 107 classes, like, I can't help you, or wait. Most of them are violations of Rule 1. This is why I stuck it in. Screens, yes please. Take notes on the PDFs. However, I have seen the effect on a group of people, if somebody in the front especially, started watching a cat video. All of a sudden the nose is sort of goes drift off me, and everybody's sort of focusing on the screen over there, and there's clearly something really interesting happening. Please don't do that, right? That's a Rule 1 violation. So other than that, please use it, but use it for class stuff. It's very easy to get distracted. It's very easy to distract others with that. Okay, first extra credit. That pre-post test. I'm handing you a test soon. That's for me, again, to improve my my teaching. I've been doing this for 7 years now, and I've given this test pre and post the class every time to see what topic I do I need to go over better, what can I explain better, what can I work on. This has nothing on you. You can flub this as hard as you want. Okay, this is for me to figure out what you had in high school, what you had from watching the Discovery Channel. Like, who walks into my room, right, is very different for this university to one that's in California versus one that's in New York versus in Florida. This is a standardized test for that reason, so that I can compare how I do, right? How much do I improve your knowledge after you walk in? You got memes. You might notice the occasional meme here in my slides. They are very old, like I am. That's fine. I'm trying to improve them. If you've got some funny astronomy things, I love those. Please send them along. Extra credit for you. You got a better mnemonic for the stellar types. This is where all of you are language gifted will absolutely help me get a better mnemonic. When we get the stars, I will point that out to you. There's a new one, what if we get it right? I talk about global warming because I talk about planets and planetary atmospheres for a week. It's depressing to basically go, oh, everything's getting hotter because of CO2. I'd love to hear from all of you, oh, what would it look like if we get it right? Because it feels condescending to just say, look, this is happening, it's your generation that has to fix it. That just doesn't sit right with me. So what would it look like for you, for your job, for your living situation, or like your parents or whoever? Like, what would it look like in the future when we get it right? And so each of those are 10 points out of, on top of the 300 that you can get extra credit. I forgot one. There is also something where you can talk about a constellation. We'll talk about constellation in a few weeks, where we talk about the different types of constellations and the different culture constellations. So if you're like, hey, this is great, I know a little bit about the Lakota, I am going to talk about this Lakota constellation, for example. Feel free to do that. Okay, so voting. Is there extra credit in this class? Yes, no, I don't know. What? Voting in 1, 2, and 3. Thank you. Yeah, this is how I keep you all awake in the dark room, right? Like you asking me questions. How much is the pre-class prep worth? 10 points, 100 points, 30 points when 100% completed, 30 points when 70% completed. Voting in 1, 2, and 3. You all got it. Fantastic. Okay, how much is the homework worth? 1, 2, 3. Yeah. How much is the pre-class, the in-class, and the homeworks worth? 10 points, 100 points, 30 points when 100% completed, 90 points when 70% completed. Voting in 1, 2, and 3. It's 90% total if you do 70% of each category. Right? This is how I check how awake everybody is. And I know that some of you work at UPS and therefore are here on like a nap, and then you show up here and it's a nice comfortable chair, and it's warm, and it's dark, and if I start talking in monotone, you'll just nod off whatever I do. That's fine, but I want to make sure that most of you got it, and that's how I check it. How many points can you get in total? 300, 100, 70 points, 100%. Voting in 1, 2, and 3. You can get 300 points, and if you put in extra credit, and you're starting today, you will get extra. You can go over 300 points. I am fine with that. I'm paid no matter what if I give everybody an A+ or everybody fail. I never had to give everybody a fail, but I have given a large fraction of this class an A+, and I'm good with that, okay? If you happen to have a cool picture of the solar eclipse, just imagine the amount of planning that went into that one. Absolutely, if you still have one where it's like, yes, we were there, or like I was there with the barbecue. I like these kind of things, so if you send it in, I might actually give you some extra credit as well. So if you have a cool picture like that. Last semester, people saw the aurora, and people's phone cameras are so amazing now that they capture the aurora. It's like, hey, if you got a picture of the aurora, I want to see it. So please do, right? We got some cool pictures of the eclipse. Or, if you're in the International Space Station, or actually higher than that, you can actually see the shadow itself. All right, about emailing. Help, the video and PDF isn't up. Definitely email me. I spaced or something. Technical issues, I forgot, pick with Knievel, something or other. This is why it's not up. Other questions, please use the Reach Center. It's on campus. I'm sure within a week or so I'll get an email like, hey, please give everybody, let them know about the Reach Center. Yes, go here. If you have a question, there's older students, grad students who are willing to help you with that. If you scan this, I think that's still okay. That's reach.louisville.edu. That's where you can get help. You can also get help with other classes. So go there first. But if you're on campus, you go like, all right, I have an assignment due on Friday. Let's go to the Reach Center. Let's go there and get help. I also, the sort of flip side of this is if your semester starts to resemble Calvin's desk here, which for the record is on fire, this happens, okay? I try to make the class as flexible as possible, and yet real life happens and it sort of drove off a cliff. I get it. Here's the thing. The more runway you give me, the more I can help you. If you are waiting until after the final, at which point I have 48 hours come high or low or high water to hand in my final grades, I have zero flexibility. If halfway through the semester you go, I'm going to have to move home and help my mom with this, because, you know, stuff. Okay, we'll work on something, okay? That's fine. That gives me flexibility. But it comes down to when you contact me. I run out of runway after the final. They're basically going, tick-tock, where's the final grade? I have no, like, my hands are tied. Earlier than that, we'll work something out, okay? I'm happy to be flexible. You go like, I'm gonna have to move back and my internet's terrible there. It's like, fantastic, write the final essay, done, right? We'll just turn the whole thing into final essay or something. I'm creative, don't worry. But if you are stuck on something, if real life intervenes, the earlier I know, the more I can help you. You good with that? It will happen to one of you. Something is going to sort of throw a spanner into the machine. So as a result, I go do all my communication either over Blackboard messages or preferably email. There's two reasons for that. There's one location where I go where it's like, oh, I talked to a student, I got a question, and who was that, right? I just go back into the folder of all the emails that I got from this. The second part is I have a paper trail, you have a paper trail. That is useful and has proven useful. That's why I don't do texting, Slack, other communications, because I don't know where that went. So it is a little old school. I know you're not the generation that likes email. This is the reason that professors like email. It's in one class folder. And so just a little bit on that. Did we do anything in class? No, we all sat quietly here. There's a recording of it. Dave, I'm like, yeah, Dave. I don't know, Dave, there's a lot of you. So don't do this. Maybe he's like, hey, the assignment's not up. Or hey, because hey, maybe I didn't toggle the little switch that says visible to students, which is a silly oversight on my part. So yes, absolutely let me know. And also, you know, student, last name and number. I can find you. If you go like, hey, I didn't see my assignment didn't get graded. If you give me the number, I can find you. If it's just Dave, I have to go past all the Daves. And that might be a long list. So I try to do that, right? Same thing for you. I try to keep human hours. I actually have a life outside this class, believe it or not. I don't live here. And so Google and check the syllabus first, and point anything that you need help with. That's fine. But 9 p.m. on Thursday night, I'm not answering emails about homework. You should have started a little earlier than that. Online material is supposed to work on tablets and phones. Let me know when it doesn't. I've prepared this on a laptop. It might not work on a tablet. We had an issue with printing on PDFs, that kind of thing. So, if you don't get an answer, it might just be in the syllabus. I think this is a little, it's a meme. I saw it, found it funny the first time, now I find it meme. I check, we put stuff online for you, okay, but that's it. And therefore, I also want to have drop-in hours. So I am going to find a space on campus that I can have the drop-in hours. Currently, I'm homeless, basically officeless, so we'll do that way. There is a class recording. This one's the first one getting recorded. Best effort on my part, right? So technical issues aside, you might be heard on that recording. I hope you're all okay with that. I mean, you're kind of like, I might hear a little mumble, that's me, but okay. So, just to reiterate, Tuesdays, pre-class video, reading, pre-class assignment, lecture, in-class assignment is lecture, so like sort of like that's what we do in class. Thursday, pre-class video or reading, pre-class assignment, planetarium, in-class assignment. So we do things like a planetarium show, like it's not the full show often, but it's like showing the concept on the dome. And then on Friday, the homework's turned in and I'll have drop-in hours so we can work on topics and issues. Yeah. Nodding all around, nodding off all around, it's okay. All right. So, we'll talk about science. Like this might be your only science class, and I realize that that's putting a lot on my 3 credits here. So I'll try to go by how science works and how we test these things in astronomy. And astronomy being a slightly different science than all the other sciences, but we start with a hypothesis, an idea that can be tested, right? So this is what the trained dinosaur said. Anyone dinosaur trained? My kids were like dinosaur trained, so that was a big deal. And suddenly that comes out in TV. A hypothesis is an idea that can be tested. A theory is a narrative that is consistent with the observations. A theory is often a bunch of hypotheses that have already been tested. So not a belief system, not something, if I say I believe it, I should be saying I have been convinced, but I'm convinced by this theory because of the testing, because of the observational evidence. So astronomy is an observational science, meaning that we can't tweak anything. We can't move the star to the left, we can't flip the sun around, we just have to wait until we see developments. Usually if you talk about chemistry or physics, you're in a lab, so you control everything, temperature, humidity, whatever you like. There's a button for it somewhere, and you can test everything and change one thing and see if it makes a difference. For astronomy, you go like, well, I'm hoping everything is still the same except time. So with observational science, you just have to wait and see. We learn, this all can be scratched. I love when I get to update slides because our science has improved in the meantime. So you'll see this on occasion that I suddenly have to slide this out. Astronomy up until 2017 learned all it can from light, electromagnetic radiation. Now it's almost all. So we cannot change the experiment, we can just observe and then carefully reason out. So form a theory and test predictions. So you can make a prediction, this is what it should look like in 6 months' time, for example. If you're starting to feel like this, where you feel like a tiny insignificant speck lost in a cold, uncaring universe, that I'm doing my job, I put the comic in because I completely disagree with this. Right? We're in the only planet that is, as far as we know, that's welcome to us, that's suited to us, and we are the only people looking. So actually, I think that makes us pretty special. There are a lot of terms. Again, my friend, the research says, so like if you're doing it wrong, you're basically teaching as many new terms as French 101. I'm trying to avoid that. All of these are bollocks, by the way. They're absolute fakes. I'm also trying to do minimal dead white guy content because I've seen these slides in my classes. So Sir Anthony Quibble, discoverer of the now disproven planet Vulcan, super important in the development of the Royal Astronomical Society, or the third hit on awesome mustache on Google. You can tell, and neither can I, right? Why am I showing you this picture? So I'm avoiding that as much as possible. Occasionally I'll have to put in a name. Usually that's sort of like, well, this is the first person that found this out. Science is a team sport. It's never about one single genius. So the topics are, what is science? That's this week. Light, gravity, and the scales and times of the universe. The first 3 weeks we go over these major components of astronomy. We go over these major concepts. We're not starting off, here's planet Earth, solar system, bigger than that, bigger than that, bigger than that. That's sort of traditionally how the book is set up. I thought it might be better to start with light, gravity, and scales, the times, like how big things are. That's sort of all you need to understand astronomy. There are other forces in nature, but gravity does 90% of, well, 99.9% of it on large scales. So we don't need the other ones. How do we learn about all of them? Well, if it emits light, we know about them, and if it doesn't emit light, not really. And then we learn about things slowly, or it takes a long time to figure this out because the scales and times, the time scales of the universe. So those are the 3 things that I want us to get started on, and then we use these concepts over and over. We're like, oh yes, that was gravity. We learned that in the gravity week. So now we use gravity, for example, in exoplanets. Now we use gravity on the scales of galaxies. We talk about the night sky, so what you actually can see, so sort of how we started as a species with astronomy, like the things that you can see. And I'm very curious what you have seen of the night sky to begin with. Some of you may have lived in Louisville, there's a lot of light pollution, you might be able to recognize Orion, and other people, it's like, yeah, I was in the Boy Scouts, we went camping, and I saw the whole thing, the Milky Way and everything. It's very different for different people. Stars, when we talk about the formation, the lifetime and the end of stars, so that's a couple of weeks. Planets, including the ones nearby, so that's how I do it, talk about the solar system. We've learned about a lot new planets, so we talk about planets as a thing, and then also the ones that we can really study, the ones close by, the ones you can see with the naked eye. And then I'll stick in telescopes to the night sky. Galaxies, that is my particular profession, so I stuck it in at the end so that I wouldn't talk the entire semester about galaxies because I can, I just don't want to. And then cosmology, basically the universe as a whole. And so all of these are sort of 1 week or 2 weeks, and so those are the things that we'll talk about. So who is an astronomer? Voting again. Anyone who owns a telescope, professionals with a PhD in astrophysics, anyone who examines the night sky, people who work for NASA. What do you think the best answer is here? Voting 1, 2, and 3. I got mostly C and a smattering of B. So professionals with a PhD in astrophysics, sure, but that makes it a very small group, right? That's about 10,000 people on the planet. Meanwhile, anyone who examines the night sky, there are people who do this for fun, as a hobby. Sometimes it's just a misnomer to call people amateur astronomer when you see what they actually do, the photos they take, or the science they do. So it's not a requirement to have a PhD in astrophysics to be an astronomer or to be interested in astronomy. So what is astronomy? The study of the night sky and the motions of stars and planets, the science of planets, stars, galaxies, and the universe based on observations, the study of anything that happens in space, predictions on how planets and constellations affect people's lives. Wording in 1, 2, and 3. A, B, and C here. So this is the part where, just to practice, I go, okay, turn to your neighbor, and even if the two of you agree, convince them why your answer is right. So yes, you got to sit next to somebody to make maximum use of this class. Turn to your neighbor, even if you two of you agree, explain your answer to them. You have about 90 seconds, or basically my lap time around that day. Again. So this is not terribly long, but so explain your answer to the person next to you. Voting in 1, 2, and 3. It's always fun to me to watch who convinced who. Red over here and blue and green over here. So that's when you're like, okay, let's go over the answers. The study of the night sky and the motions of the stars and planets. Sure, that's how it got started, but thanks to much more powerful telescopes, we can see much further. So it's no longer stars and planets anymore. The science of planets, stars, galaxies, and the universe, okay, that's encompassing a lot more, based on observations. Okay, that is a general enough statement to sort of cover everything that we do in astronomy. The study of anything that happens in space, as it turns out, just studying what an astronaut does or how his kidneys function, not part of astronomy. Happens in space though. So there is something like planetary science, which studies the geology on other planets, for example. So anything that the Mars rover does, planetary science. Predictions on how planets and the constellations affect people's lives. That's how we got started. Basically, we started with this, realized that the planets and especially the constellations were a great way to keep time in a calendar. Oh, we can predict when the bison come back. We can predict when the barley starts sprouting. That's great. And then we sort of extrapolated that as early humans and went, oh, we can also predict when the king's going to die. And that turned out to be a little bit of an overreach. So that's where the astrology comes from. I know a lot of professional astronomers like to bash astrology for the following reason. They feel like it's a scam and people are getting scammed, and that worries us, right? However, if that gets you to eat a salad, great. It's not in the planets though, it's just a good idea to eat a salad. And so predicting that was sort of an overreach from when you saw that the calendar was a fantastically powerful tool, and it was like, oh, I can predict like migration patterns. Now, if you are completely dependent for your livelihood on when the wheat comes in or the bison show up, this is a good thing to know. Like, oh, that constellation's back up, the bison should be coming through any day now. Better get ready. Like, that is a superpower, right? So it felt like, oh, this is a superpower, and then extrapolated to individuals because that's how our brains work. We think in individuals. Okay, got it, but that's not how it works these days. All right, critical units. I'm just going to give you a couple of like funny stories why we use units in physics. In 1999, a rather expensive $300 million Mars climate orbiter disintegrated after encountering Mars's atmosphere. It turns out that one piece of software used imperial units, and another that actually went into the onboard computer that went into metric. Two different contractors used two different units. They looked close enough, and they didn't get the last, hey, can we do a units check? So actually it should have been 328 plus whatever 4 tickets for a couple engineers would have cost them, because then they could have gotten everybody in one room and do one final check that everything used the same units. Because hey, pounds per square inch and pascals, roughly the same numbers, it looks the same. So yeah, it's important to sort of do that final check. There's a lot of these things, right? So 1628, the Swedish warship, the first one they built, the Vasa, sank in less than a mile into its maiden voyage. It came down that one half of the ship was built to Swedish feet, and the other one using Amsterdam feet, which is 11 inches. Essentially, you had two teams of carpenters, and one built one side, and the other one built the other. And now one side had 12-inch thick, or like used planks that were were on the Swedish foot, so the one side is heavier. The whole thing is flipped over. So, yeah, it happens all the time. And then also, Air Canada switched to the metric system in the 1970s, and then, or for example, when Sweden switched from driving on the left side to the right side. It's a fun traffic crash when that happens. And so you went from like, hey, do I put in liters or gallons? Well, 1 gallon is 3.7 liters, so if you still put in the same number, you're not going to get as far. This is the nicest one. There's more of these, and they're just sort of, nobody wants to fly after those stories, so I'll just keep it to this. What it comes down is that, hey, if we all use the same units, we can communicate better. So in part, this is a communication class, right? If you're talking communication, be clear. And clear new communication means that, oh, we're talking about the same thing, yeah? So the same thing is done with the Système International, the kilogram, meter, second, ampere, Kelvin, mole, and candelat. These are the things that we use all over science for this reason, because somebody in Senegal should be reading my paper and understand the units I'm using. For this reason, we sort of do not use imperial. You go like, you sound military because you say everything in kilometers and keys and kilograms. Not really. This is how scientists speak. This is why we adopted the international system. Okay. That said, there's a lot of units that sort of go with that. A lot of them are for electrical systems, for example. Also important to do that. And then, because we were dealing with large numbers in astronomy, so really large scales, so large numbers, we do deca, hecto, kilo, mega. You've heard of some of those. Yeah, like decathlon is something that people do. A gigabyte, right? So this is the amount of bytes that you have, a megabyte. I don't think anybody here has, it's going to be like 2 people in the room, including me, who's heard of a megabyte. Everybody else has gigabyte people now. Maybe your internet's a little slow and it's still on megabytes. Anyway, so gigabytes is 10 to the 9, terabytes 10 to the 12, so it's in steps of 3. three extra zeros behind it. So we talk about these, goes back to zeta and iota. I think this is especially a fun one. Peta is how we do the biggest computers computing speeds these days. But then you can also go smaller. So a tenth is a deci, a hundredth is a centi, a thousandth is a milli, so a millimeter is a thousandth of a meter. Micrometer, so the mu is the 10 to the minus 6, that's a millionth. A nano is a billionth. Pico is well, 1,000 billion, so the converse, so 1 over 10 to the 12. Femto, atto, zepto, and yocto. I honestly have never used yocto other than in this class, but a lot of these other ones are good to say what kind of scale you're talking about. So for example, we have a pico femto, we have a picometer, a lab here on campus that works in the very, very small. And so if you put that in front of the unit, then you know how much smaller, how much bigger than that one unit. Temperature is, for example, measured in Kelvin. 0 Kelvin is absolute zero. Literally everything is frozen in place. The coldest temperature isn't quite there yet, but like, let's see, 3, another 3, another 3. This is a billionth of a Kelvin. So that is a nanokelvin. At the nanokelvin scale, it's as cold as we've managed to get anything in the lab. 2.75 Kelvin is the present temperature of the universe. So the stuff in the middle of in stars is 2.7 Kelvin. Look, that's only a couple of degrees above absolute zero. Nitrogen boils at 7 Kelvin. Room temperature is 300 Kelvin. So that's 253 plus whatever room temperature is. So this is the same scale as Celsius, but you start at absolute zero. I'm used to thinking in Celsius because I'm from Europe, but I know that all y'all think in Fahrenheit, but anything that is done in science is usually in Kelvin, so you start at zero. So you have things like water boils, and room temperature on Venus, and then the surface temperature of the sun is about 5,000 Kelvin, almost 6,000 Kelvin. Visible surface of Sirius is almost 10,000 Kelvin. The core of the sun is at 16 million Kelvin, and the thermonuclear weapon, like this big boom here, is 350 million Kelvin. So it gives you the kind of temperatures that you work with. Because it's astronomy and it's really inconvenient to say 10 to the 33 kilograms, we sort of work in solar relative to the sun units. So solar masses, solar luminosities. If we put this little O dot here, this little O with a little dot in the center there, it's called the O dot, but that's the zodiacal sign for the sun. We still use the zodiacal signs, by the way, right? The ones from Mars and stuff like that. And then this is the one for the sun. So this is the unit for one solar mass, because it's easier to say one solar mass than 10 to the 33 kilograms every time. Light years, how long, the distance for how long light travels in a year. An astronomical unit is the distance between the Earth and the sun. The parsec is another measure of distance. We'll talk about that later. This is the most commonly used one, but you need some technical background for that one. And then the angstrom is for wavelengths, which is 10 to the minus 10. So it's not, it's 10, it's a tenth of a picometer. For some reason we use this. A lot of this is historical reasons. Why do we use imperial units here in the US? We have nothing to do with the British Crown. Well, we always use them. Our dads used them, and therefore we still use them. Everything in my wood shop is still in inches. That's why I measure everything in inches, right? So a lot of these things are historical record. Like you start doing this, and then you just keep doing it. So that's how we end up with like you'll see this come by. Why are you doing this? Oh, right, because the first plot was made that way, and then. So when I do an expression, I'll try to work out a problem, and I'll put the units between square brackets so we can actually see how the units work and how units, for example, cancel out, and see how the units match with our answer. All right, so I have the pretest. I feel like this is the most talking I will do in the semester. Usually, I hand something out, we work on something together. This is, I can feel it already, that this is the longest I've been talking. Because I've already gone over my 20 minutes, and I think you forgot a few things that I've said. It's fine. So I'll work on we can work on the test on this short test already. So this is for me to gauge how do you feel about astronomy. So that's one thing that I was curious about, but mostly to see how I'm doing for this class. So you're helping me improve my class, and that's much appreciated. And this is the first extra credit. How do I get this to move? Turn it into quick outline. Shouldn't take long. And again, feel free to get everything wrong, because then I look good at the end of this when you get everything right. But don't do it on purpose, because I actually want to generally know what you know already. I think my first class that I ever taught, I had a retired physics professor in my class, so we knew a lot already. And that's good for me to know, because I'm like, oh, I'm doing really well, and turns out, yeah, no, this person knows all this stuff already. I don't want to know that. I don't want to see how well I do. So it's 5 points for this one, and at the end of the semester, if you do this one as well, like we do this in the last class, I run through final exam questions so we can practice. My entire thought process behind this class is I know how many classes sort of end up with doing half the material at the end of the semester. Not this class. We are already done. You know what your grade is roughly going to be. You're like, I just have the final to knock off and then I'm done. I want you to be relaxed going into finals week regarding this class. This is not going to be the worry in finals week. That's my whole point, my whole goal. So that's the philosophy behind the class. I'll stop the recording because I'm gonna try to do the planetarium. Again, best effort.